Okay, June exam, paper 2, question 1. In the diagram, A, B, C, and D are the vertices of a rhombus. The equation of BD is 3x minus 0 is equal to minus y is equal to 0. The diagonals of the rhombus intersect at point K. Vertices, so remember vertices is where two lines meet together, né? So those points over there, those are your vertices. Okay. An important characteristic of a rhombus, diagonals bisect each other. They also bisect at a 90-degree angle, and then all four sides are equal. Okay, 1.1. Calculate the perimeter of ABCD. Leave your answer in simplicity form. So what we need to do, seeing that we have these coordinates, we can find the distance of this. And because we know that all four sides are equal, we just multiply it by 4. Okay, so let's do that. So the distance of AD negative 8 minus 3 and 6 minus 9 squared. Okay, negative 8 minus 3 is negative 11. 6 minus 9 is negative 3. That would be 121. That would be negative 3 squared would be 9. So that's square root 130. Okay, so that's the length of one side. And then we need to multiply it by 4. So we can say therefore perimeter of A, B, C, D is equal to 4 times root of 130. Okay, 1.2. Determine the equation of the diagonal AC Determine the equation of the diagonal AC in the form of y is equal to mx plus c. Okay, so we have a coordinate a that we can substitute in the place of x and y, but we don't have the gradient, né? But they did give us the equation of BD, right? So from that equation, from the equation of BD, I can determine the gradient of BD. And because the diagonals intersect at 90 degrees, that means that AC and BD are perpendicular to each other. So the gradient of AC would be the negative reciprocal of the gradient of BD. Okay, so the starting point is to find the gradient of BD. So I said BD was 3x minus y is equal to 0. Now I'm going to make y the subject of the formula. So that would be, if I were to take y over that side, it would be y is equal to 3x. So I'm going to write it as y is equal to 3x. So therefore, the gradient, so I can see the gradient is 3 there, right? So therefore, the gradient of AC would be equal to negative 1 over 3. Because AC is perpendicular to BD. Alright, so now I can go back to the standard formula. Sorry. Right, now I'm going to substitute the coordinates of A as well as the gradient. So y is 6, gradient is negative a third, x is negative 8 plus c, that's 6 is equal to 8 over 3 plus c. If I were to write 6 as a fraction as something over 3, that would be 18 over 3. So I bring the 8 over 3 over, that's minus 8 over 3 is equal to c, that's 10 over 3. So therefore, my equation would read y is equal to negative a third x plus 10 over 3. Okay. Next question. Calculate the coordinates of k if the equation of AC is x plus 3y is equal to 10. Okay, so what we can do there is now, because we have the equation of AC and we have the equation of BD, we can do simultaneous equations to find k, because k is the point where the two lines intersect with each other. Okay, so 1.3. So we've got the two equations. We've got 3x minus y is equal to 0. And we've got x plus 3y is equal to 10. Okay, I'm going to make that equation 1, make that equation 2. Okay, so we're going to do substitution method now. You could also do elimination method, it's fine. But let's go with substitution. So we know that this is also, so from 1, we know that y is equal to 3x. And then we're going to so let's make that equation 3. We're going to substitute. Okay, I'm going to continue on the next page. Yeah. So I'm going to substitute wherever I see y, I'm going to substitute it with 3x. Okay. Yeah. So we substituted equation 3 into equation 2. Okay. So that's x plus 3 times 3, x is 9x is equal to 10, so 10x is equal to 10, x is then 10 over 10, which is 1. Okay, then I substitute that back into one of the equations. Let's substitute it into equation 3. So y is equal to 3 times 1, y is equal to 3. So therefore k is 1 and 3. Okay, next one. Calculate the coordinates of B. So now we've got on this line BD, we've got D, we've got K, and we've got B. And where K, because diagonals bisect of a rhombus, that would be the midpoint over there. So we can use the midpoint formula to go and solve the coordinates of B. Okay, so the midpoint formula, so we're going to do the x's to the left and the y's to the right. So the x value of the midpoint is 1, and one of the x's is 3 plus x2 over 2. Now the y's, The midpoint coordinate of the y's is 3. Other one is 9 plus y2 over 2. Okay, cross multiply. 2 times the 1 is 2. Take over the 3. That will give me negative 1 on that side. Cross multiply. That's 6. Take over the 9. Becomes minus 9. 6 minus 9 is negative 3. Okay, so therefore the coordinates of B would be negative 1 and negative 3.